Hi, for today we are going to have a lesson on quadratic equation. Before we start, let me introduce you to our teachers for today. First of all, my name is Nurfaisha Azati Betio Marizal and I will be one of the teachers for today. Next, we have Muhammad Ifan Iman, Nur Shakira binti Zakaria and Nurul Iza binti Muhammad Basiran. They are also will be giving a lesson for today's lesson session. Now that we are done with our introduction, shall we start lesson? Once again, my name is Nurufaisha Azanti with my result. I will be giving lesson on quadratic equation and equalities.
Do you know how to distinguish a quadratic equation? What about its characteristics? Okay, let me teach you how to know an equation is a quadratic equation or not. What you see here is a general form of quadratic equation. It has three characteristics that is important for you to remember. The first characteristic is the coefficient of x squared cannot be 0. Next, the highest power of a variable is 2. Lastly, the third characteristic is that there is only one variable in each equation. Simple, right? Now, moving on. We will be learning on how to solve quadratic equation. We can solve quadratic equation by using two methods, which is completing the squares and by using the formula. First method is completing the square. Let's do an example so that it will be easier for you to understand. The question will be solve the following equation by using the completing the square method. For question A, the solution will be, first, you have to move the constant 7 to the right side of the equation. Next, add the terms b over 2 squared into both sides of the equation. In this case, the b will be 4, and we know that from comparing it with the general form of the quadratic equation. Next, simplify the equation. For the right side, simply solve for the answer, and for the left side, we can simplify it to become x plus 2 power of 2. This equation is derived from the formula shown here in this slide. Then the last step we will solve for the values of x, and in this case, this will be the value of x. Moving on to the question B. Now, for question B, we cannot directly solve the equation. In order to use completing the square method, we must make sure that the coefficient of the highest degree of 2 must be in 1. In this case, the coefficient of the highest degree is negative 3. Therefore, we must eliminate the coefficient by dividing the equation by negative 3. Then, only after that, we can follow the step just like in equation A, which is first move the constants to the right side of the equation, then at both sides of the equation the term b over 2 squared, and in this case the b will be negative 2. Next, solve the right side and simplify the left side. Then lastly, solve for the x. And there we have it. X will be these values. Moving on to the next method, the formula method. Now, this is the easiest way to solve for the quadratic equation. The formula for solving the equation is this. Now, let's do one example. The question will be solve the equation by using the formula. The solution will be, we know that the general form of quadratic equation. And then, from the equation, the given equation is this. Compare both of them, and from there we'll get the value of A is equals to 2, B equals to negative 2, and C is negative 3. Then just simply substitute the values into the formula, then solve for x, and in this case, this will be x values. Easy, right? You guys still with me? Okay, now we are entering new mini topics for this session, in which we will be learning on how to form a quadratic equation from given root. Remember the general equation of quadratic equation? Good. Now, the general equation can also be written as this. If alpha and beta are the roots of quadratic equation, then we can write it as this. From there, we can expand it and we can get this equation. Then, if we do the comparison between equation 1 and equation 2, we notice that we can get this equation. Therefore, From there, we can make a conclusion that the sum of root will be this and the product of root will be this. From there, the general form can also be written as this. Now, let's try a few examples. This is the first example. Now, to solve this, first, from the question, we are given roots alpha equals 3 and beta equals -5. Then from there, we proceed by finding the sum of roots using the formula, in which we get -2. And then we will be finding the product of root, in which we will get -15. Last step will be substitute the values into the formula. Hence, the quadratic equation formed from the roots 3 and -5 is this. Do you guys get it? It's okay. Let's try another example. This is another example. Now, for this question, they asked to form a quadratic equation with the roots alpha plus 3 and beta plus 3. To solve this type of question, first get the values for a, b, and c by comparing the given equation with the general form. Then substitute the value a, b, and c into the formula. From there, we can get alpha plus beta and also alpha times beta. Now, this is the sum of root and product of root of alpha and beta, not alpha plus 3 and beta plus 3. Hence, from here, we will find the sum of roots and product of root for alpha plus 3 and beta plus 3. For the sum of roots, this is our equation, and we can simplify it into alpha plus beta plus 6. Then, we can substitute the values of alpha plus beta. Solve it, and we get the sum of roots is equal to 11 over 2. Same concept for solving the product of roots. Solve it, and we will get 11 over 2. Lastly, when we have both values, we can substitute both values into the formula, and from there, we will get the quadratic equation for the roots alpha plus 3 and beta plus 3, which is, this is the equation. Now, you can choose to leave your answer like this, or you can simplify it by times 2, and thus you will get this equation. Last but not least, the last mini topic that I will teach for my session will be on solving quadratic inequalities by using three methods, which are the sketching graph method, number line method, and table method. Quadratic inequalities are normally written like this. In order to solve the quadratic inequalities, we must find the range of values of x that can satisfy the quadratic inequalities. As usual, let's look at the example for better understanding. Now, this will be the question. Now, let's look at first method, the graph sketching method. To solve this question, first, take the equation and simplify until the right-hand side becomes 0 and the left-hand side is in its simplest form. In this question, after we simplify it, we get this equation. To draw a graph, make the equation equal to 0 and then sketch a graph. We know that it is a smiley graph because it is a quadratic equation. We also know the x-intercept, which is -4 and 1. Since we are looking for solving inequalities that is more than or equals to 0, the values of range of x should be more than 0 or above 0. Hence, it will be positive value. Therefore, from there, we could clearly see that there is positive value on the graph, which is this. This is how you solve the quadratic inequalities by using graph method. Next, let's check the next method, number line method. First, solve it to the simplest form. Then draw a number line and let the equation equal to 0. From there, we will get x equals to -4 and x equals to 1, which will be our mark. And from there, we can find the value of x that satisfy these inequalities. Solve using the values chosen, and from there noted the positive value only, since we are solving for the equation which is more than or equals to 0. Hence, the answer will be this. Lastly, the table method. The method is more or less just like a number line method. However, in this case, instead of using number line, we use table. First, solve the quadratic inequalities into its simplest form, then copy the exact table as below. Complete the table by adding positive and negative sign for each factor of the quadratic inequalities. Find the value of x that will satisfy these inequalities. Substitute the value into x plus 4 and x minus 1 to find the to find out whether the values will be negative or positive. From there, we can get the sign for x plus 4 x, and x minus 1. Our answer will be positive signs if we are looking for the equalities that more than or equals to 0. Therefore, the range value is this.
That's all from me. Hope you managed to catch what I have been teaching you for today's lesson.
Assalamualaikum and hi everyone. I am Iman and I will explain about the subtopic 2.2 of chapter 2 quadratic function, which is types of roots of quadratic equation. For your information, an equation of the form of ax squared plus bx plus c equals to 0 with the value of a is not equal to 0 is called quadratic equation. The standard form of quadratic equation is ax squared plus bx plus c equal to 0, where a, b and c is the real numbers and the value of a is the coefficient of x squared, b is the coefficient of x and c is a constant. This is a example of quadratic equation in variable of x, but always remember that the value of a is a non-zero value. Now, to find the types or the nature of the roots of the quadratic equation, we will first calculate the roots of the equation. Natures of roots specifies that the equation has real roots, irrational roots, or imaginary roots. Imaginary roots are also known as unreal roots. The types of roots of quadratic equations can be determined from the value of b squared minus 4ac. D is called a discriminant because it discriminates the value of the quadratic equation based on its sign. The discriminant is used to find the nature or the types of roots of a quadratic equation. The discriminant is also known as D. So there are three types of roots of a quadratic equation. First type is real and distinct roots. The discriminant D is positive. That is, b squared minus 4ac is larger than 0. This curve will intersect at the x-axis at two distinct points. Note that if the discriminant is a perfect square, the two roots are rational numbers. And if the discriminant is not a perfect square, the two roots are irrational numbers containing a radical. Next, the second type is real and equal roots. So, the value of the discriminant is equal to 0. That is, b squared minus 4ac is equal to 0. And the curve will intersect at the x-axis at only one point. The third type is called imaginary roots. The value of the discriminant will be negative, that is, b squared minus 4ac is smaller than 0. So, the curve will does not intersect at the x-axis at any two distinct points. So, for your information, the imaginary number, which is I equals to set negative 1, will occur when the quadratic equations have the negative values of the discriminants d and there are no roots in their solution. So, if b squared minus 4ac is a negative value, the quadratic equation is going to have imaginary roots containing I. So next, This is an example to find the imaginary or complex root of the equation, which is x squared plus 3x plus 4 equals to 0. So, this quadratic equation is not factorable. Thus, we must apply the quadratic formula. The roots of the quadratic equation ax squared plus bx plus c equal to 0 is equal to negative b plus minus z b squared minus 4ac and all over 2a. Here, if we compare to the quadratic equation that is given in the questions, we will have a equals to 1, b equals to 3, and the value of c is 4. So we must apply in this in the formula that we have the roots. The roots of equation is will be minus 3 plus minus 3 square minus 4 times 1 times 4 all over 2 times 1. So we will get the value of minus negative 3 plus minus z negative 7 all over 2. So we must separate the z negative 7 into the z 7 times z negative 1. So we will get the answer is negative 3 plus minus I z 7 all over 2. So therefore the two complex root of the quadratic equation will be first negative 3 plus I times z 7 all over 2 and negative 3 minus I times 7 times z 7 all over 2. So this is an example to find the types of the roots. So the question state that LC has a 2-digit secret number. She gave a few hints to her friends Mia to crack it. She says it is the value of the discriminant of the quadratic equation x squared plus 9x plus 14 equal to 0. So can you guess the lucky number? So for the solution, first we know that the quadratic equation is x squared plus 9x plus 14 equal to 0. So we compare it with the ax squared, the general equation of quadratic equation, which is ax squared plus bx plus c equal to 0. Thus we get a equals to 1, b equals to 9, and c equals to 14. So let's use the discriminant formula to find the discriminant. So the discriminant will be equals to b squared minus 4ac. So we get 9 squared minus 4 times 1 times 14. We get 18 minus 56. We will have the discriminant value is 25. So the lucky number is 25. So if we want to relate with the types of the roots, we will get the discriminant. We get the discriminant is 25, which is larger than 0. So if we want to find the roots of the equation given, they will be the root of types of real and distinct roots. First types. So because the value of discriminant is larger than 0. Next example is Flora love collecting flowers. So there is 5 flowers which the number 5, 6, 7, 8 and 9. So she wants to choose a number k such that the quadratic equation kx squared minus 2kx plus 6 equal to 0 has real and equal roots. So each of the flowers, as I said, has a number and the answer to this question is shown on the flowers. So can you help her find the answer? So for the solution, we must compare the quadratic equation given, which is kx squared minus 2kx plus 6 equals to 0, with the standard form of the quadratic equation, which is ax squared plus bx plus c equals to 0. Thus, we will get the value of a is k, the value of b is minus 2k, and c is 6. So, as the both of the roots of the quadratic equations are real and equal, the value of the b squared minus 4ac will be 0. So we must use b squared minus 4ac equal to 0. Substitute, we will get negative 2k all square minus 4 times k times 6 equal to 0, and then we get 4k squared minus 24k equal to 0. Factorize, we get 4k times k minus 6 equal to 0. The value of k will be 0 and 6. So now the flower does not contain the number of 0, therefore the k is 6. So the correct number of the flower is 6. So the types is real and equal because the value of discriminant is 0. So that's all from me. We will move to the next subtopics. Thank you.
Now, we have arrived at the third and last section of this chapter, which is quadratic function. In this subchapter, we will learn three things, which are the different forms of quadratic function, the shape of the graph, and how to sketch the graph. There are three different forms of quadratic function, which are the general form, the vertex form, and the intercept form. In the general form, the quadratic function is written as fx equal to ax squared plus bx plus c, while the intercept form is written as fx equal to a in bracket x minus b in bracket x minus q. The p and q are roots of the function. The third one is called the vertex form, which is written as fx equal to a in bracket x minus h squared plus k, where point h and k is the vertex of the function. The three forms of quadratic functions can be expressed interchangeably using the methods shown. From the general form, we can express the function to vertex form by completing the square methods and express the general form to the intercept form by using factorization. Vertex form and intercept form can be expressed to general form by expansion. Here is an example of how we express a quadratic function from one form to another. We are given a function fx equal to 2 in bracket x plus 4 in bracket x minus 2, which is the intercept form, and we need to express it in the vertex form. First, we need to expand the function to obtain the general form. From this, we will get fx equal to 2x squared plus 4x minus 16 as the general form. Then, we completing the square methods as we have learned in the previous section. First, equate the function to 0 such that 2x squared plus 4x minus 16 equal to 0. Second, divide the whole function with 2 so that the constant a equals 1. Next, move the c constant to the right hand side. And then we will add both sides of the equations with b constant over 2 and squared. We will then obtain the function in bracket x plus 1 squared equal to 9. Finally, move the 9 to the left hand side to get the vertex form of the function, which is fx equal to in bracket x plus 1 squared minus 9. That is how we can express the function in three forms: the general form, the intercept form, and the vertex form. Now, we will observe how the properties of the function can influence the shape and position of the graph. First, we will observe how changes of constant a, b, and c of a quadratic function in general form fx equal to ax squared plus bx plus c can affect the shape and position of the graph. Second, we will see how the three different types of roots can affect the position of the graph. Finally, we will observe how the effects of changes in a, h, and k values of a quadratic function in vertex form can affect the shape and position of the graph. For this section, I will be using GeoGebra application to better demonstrate the changes in the shape and position of the graph. So first, I've already keyed in the general form of the quadratic function into the input bar. Now, I will manipulate the values of constant a, b, and c to see how that affects the graph. So here we can see that the value of a is more than 0, so that means a is positive. And when a is positive, the shape of the graph has become u. A u-shaped graph has a minimum point here. And what happened when we increase the value of a? See, the value, the shape of the graph will become narrower. And when we decrease the value of a until it becomes less than 0, we can see that the shape of the graph has become like an inverted U. An inverted U-shaped graph have a maximum point here. And what happens if we further decrease the value of a to approach the negative infinity? Here we can see that the graph, the shape of the graph has become narrower. So here we can conclude that the changes in the value of a will affect the shape and the width of the graph. And then we will manipulate the value of b. When we manipulate, like here, b is equal to 1, which means that b is positive right now. And when b is positive, we can see that the vertex of the graph is at the left side of the y-axis. When we further increase the value of b, we can see that the vertex of the graph move further to the left of the y-axis. And when we decrease the value of b to become, like, for example, less than 0, you can see that the vertex of the graph has moved to the right side of the y-axis. So here, we can see that the changes in the value of b will affect the position of the vertex of the graph with respect to the y-axis. So now I will manipulate the values of c. When we increase the value of c, we can see that the graph moves vertically upward. And when we decrease the value of c, the graph will move vertically downward. Here we can see that the changes in the value of c will affect the position of graph vertically. And then it will also change the y-intercept of the graph. Now, we will see how the different types of roots can affect the position of the graph. So here, I already keyed in 3 different quadratic functions, which are fx, gx, and hx. We can use the determinant method to find the types of root that each of the function have. For function fx equal to x squared plus 6x plus 8, the b squared minus 4ac is equal to 4, which is more than 0. Here we can see that function fx has real and distinct roots. This is shown in the graph of the function, where the graph intersects with x-axis on two points, which are x equal to -2 and x equal to -4. For the second function, which is gx equal to x squared minus 12x plus 36, the b squared minus 4ac value is equal to 0. So here, we can see that the type of root for gx is real but equal. So the graph of gx shows that the graph gx intersect with x-axis on one point only, which is x equal to 6. So for the third function, hx equal to x squared minus x plus 3, the determinant value is equal to -11, which is less than 0. So we can see that the type of roots for function hx is not real. So the graph of hx will be like this. As we can see that the graph hx does not intersect with x-axis at all. So this means that function hash have no real roots at all. Finally, we will observe the effects of changes in the a, h, and k values of a quadratic function in vertex form that can affect the shape and position of the graph. So here, as we can see, a is more than 0, so that means that a is positive, and graph, as we see here, is in the shape of U. So what happened when we increase the value of a? When we increase the value of a, the width of the graph decrease. And when we decrease the value of a until it's become less than 0, we can see that the shape of the graph has become inverted U. And when we further decrease the value of a, we can see that the width of the inverted U graph has become narrower. So here we can conclude that the changes in the value of a will affect the shape and the width of the graph. Next, we will manipulate the value of h. When we increase the value of h, the graph will move to the right. And when we decrease the value of h, the graph will move to the left. So here we can see that changes in the value of h will affect the horizontal movement of the graph. And here, the position of the axis of symmetry of the graph will change. Next, we will manipulate the value of k. So when we increase the value of k, we can see that the graph will move upward. And when we decrease the value of k, the graph will move downward. So here we can conclude that the changes in the value of k will affect the vertical movement of the graph. So when we change the value of k, the maximum or minimum value of the graph will also change. And actually, from the function, the value of h and k can be used to determine the coordinates of vertex of the graph. Now, I will recap the effect of changes in the value of constant and types of roots on the shape and position of graph in quadratic function. Changes in the shape and position of the graph of a quadratic function in a general form. The changes in the value of constant a will affect the shape and width of the graph, while the changes in the values of constant b will affect the position of the vertex in terms of the y-axis. Then, changes in the value of constant c will change the value of the y-intercept on the graph. Next, we will summarize our observation of the type of roots and their effects on the position of a quadratic function. For functions with real and distinct roots, the graph will intercept at 2 points on the x-axis. For functions with real and equals roots, the graph will intercept at 1 point on the x-axis. For functions with no real roots, the graph will not intercept with the x-axis at all. Now, changes in the shape and position of the graph of a quadratic function in vertex form. First, changes in the value of constant a will affect the shape and width of the graph. Secondly, changes in the value of constant h will affect the horizontal movement of the graph and thus change the position of the axis of symmetry. Finally, changes in the value of k will affect the vertical movement of the graph and thus change the maximum and minimum value of the graph.
Hello students, I am Miss Isa and I will explain the lesson under subtopic 2.3.5 and 2.3.6. Under 2.3.5 is how to sketch the graph of quadratic function. Some students might feel that this subtopic is hard to score since they think that it is complicated to sketch the graph based on the given function. But actually, you could enjoy sketching the graph easily if you follow these simple steps that I will explain later on. So, do you guys ready to figure out those steps? Come on, I will show you the example. Let's say if we have a question that asks to sketch the graph of quadratic function, which the quadratic function given is f of x equals to negative x squared plus 4x plus 12. In order to sketch a quadratic function graph, the first step is to identify the value of a. If you look at the function given here, the function is in general form. Still remember what is general form? General form is when the f of x is equals to ax squared plus bx plus c, where the a, b, and c are the constants. Hence, the value of a is the coefficient of the x squared. So can you see the coefficient? Yes, the value of a is -1. This means that a is less than 0. Hence, the function has a maximum point. Therefore, the shape of the graph would be an upside-down parabola. So now we are done with step 1. So let's move on to step 2. In step 2, we need to calculate the value of b squared minus 4ac. As you can see from the quadratic function, the value of a, b, and c are -1, 4, and 12 respectively. Just substitute these values into the formula b squared minus 4ac and solve for the value. But be careful not to make silly mistake by miscalculate them. Now we got the value, which is 64. Remember how is the position of the graph when the value of b squared minus 4ac is greater than 0? Yes, they will have two real and different roots, where the graph will intersect the x-axis at two different points. In step 3, we need to determine the vertex. In order to determine the vertex, we can use the formula of vertex coordinates for function in general form. Or, another way is to convert the function in this general form to a vertex form. To do this, we need to perform completing the square method. Vertex form function will provide us the value of h and k, which will be the coordinates of the maximum or minimum points. To perform completing the square method, firstly, we need to make sure that the coefficient of the x squared must be 1. So, factor out the -1. And in bracket should be left with x squared minus 4x plus minus 12. Next step is to add and subtract to the function with the square of coefficient x divided by 2 as shown here. Solve the function, and now we have this vertex form function. So from here, we got the maximum point, which is 2, 16, and we also got the axis of symmetry. In step 4, we need to determine the intersection points on the x-axis. To solve for these intersection points, let fx equals to 0. Next, just equate the given function to 0 and solve for the value of x. Factorize the equation, and there we got the values of x, which are x -2 and x equals to 6. Now, I'm pretty sure that you can already imagine the position of the upside-down parabola on the x-axis as shown in this figure here. We are close enough to fully sketch the quadratic graph. Let's move to the last step before we start sketching. The last step before we fully sketch the graph is we need to find the value of f of 0 to determine the y-intercept. So in the function, substitute x with 0 and then we will got the value 12. This means the graph intersects the y-axis at coordinate 0, 12. Now, we are ready to fully sketch the graph since we got all the information from the previous steps earlier, which are the shape of the graph, the position of the graph, the maximum points, the intersection points on the x-axis, and also the y-intercept. On this grid of x and y axis, plot the necessary points and sketch a smooth parabola passing through all the related points. And we are done with sketching the graph of f of x equals to -x squared plus 4x plus 12. Easy, right? Hopefully all these steps could help and guide you in sketching the graph of quadratic function. Now, shall we have a try to sketch the graph of quadratic function in vertex form? Come on, let us sketch together. Remember what we need to do in the first step? Yes, we need to find the value of A in order to determine the shape of the graph, whether it is a smile or it is an upside down parabola. Since the given function is in the vertex form, therefore the f of x is equals to A in bracket x minus h square plus k. So, the location of A is the coefficient of the x minus h square. Therefore, in this function, the value of A is 2. So, this means that the value of A is greater than 0. Remember, what is the shape of the graph when the A is greater than 0? Yes, the shape of the graph would be resemble a smiley, which the shape of the graph is as shown here. Now, let's move to step 2. In step 2, we need to calculate the value of b squared minus 4ac. Since the given function is in vertex form, therefore, we need to expand the function in order to get a general form function so that we could get the values of a, b, and c. As soon as we expand the function, we will get the f of x equals to 2x squared plus 8x plus 6. Now, we have the value of A is equals to 2, B equals to 8, meanwhile C equals to 6. So, as soon as we calculate the B squared minus 4AC, the value we got is 16. Remember what happened when the value of B squared minus 4AC is greater than 0? Yes, they will have two real and distinct roots. So, there are 2 points that will intersect on the x-axis. Move on to step 3, which is to find the vertex of the graph, or also known as the minimum points. Since the graph is already in the vertex form, so it is easier for us to determine the value of the vertex or the value of the minimum points, which is we could determine the values based on the values of h and k. In this function, the values of h and k is, yes, h is equals to -2 and k is equals to -2. Therefore, the vertex is the -2, -2. Hence, this means that our minimum point of the graph is -2, -2. Meanwhile, the axis of symmetry is equals to -2. Let us proceed with step 4. In step 4, we need to find the intersection points on the x-axis, remember? So what we need to do is to let the f of x equals to 0. So, do you guys remember the general form of the function that we have expanded just now? Yes, by using that general form, now we equate the function to 0. And when we factorize, we will get the values of x is equals to -1 and x equals to -3. So these 2 points, -1 and -3, will be the intersection points on the x-axis. We already reached the step 5. So in step 5, we need to find the y-intercept. In order to find the y-intercept, what we need to do is to substitute the values of x with 0. Hence, when we calculate, we got the value of f of 0 equals to 6. Therefore, the y-intercept is equals to 6. Now, we have obtained all the information required to sketch this graph. Therefore, we can sketch this graph completely since we have already know the shape of the graph, the position of the graph, the minimum point, axis of symmetry, intersection points, and as well as the y-intercept. Therefore, what we need to do is to sketch the graph completely based on the points related. So we have the x and y axis, and we have the all important points, and so sketch the parabola that passing through all the related points. Now, let's move to the last part of this chapter, which is lesson 2.3.6, solving problems of quadratic functions. This part might be tricky, but if you understood all the knowledges learned on previous subtopic, then you should be able to solve the problems. The function h of t equals to negative 4t squared plus 32t, as shown in the diagram, represents the height in meters of a firework t seconds after it was launched. The fireworks exploded at the highest point. Question A. When did the firework explode? So students, to answer question A, the keyword is highest point, since it was stated that the highest point is the point where the fireworks exploded. We know that highest point of a quadratic function is the vertex. The formula of vertex coordinates of the given function is negative b over 2a, comma, function of negative b over 2a. In this question, the value of a is negative 4 and b is 32. Now, we can proceed to find the t-coordinate of the vertex since the question asks for when did it exploded. Substitute a and b values into the formula and we got the value of t is 4. Therefore, the fireworks exploded at the time of 4 seconds. Question B. What was the height at which the fireworks exploded? The question asks for the height, which refers to function h of t. We know that the fireworks exploded at the time t equals to 4. So, to find the height, what we need to do is substitute t equals to 4 into the equation. Calculate and solve for the value. We got 64 meters. This means the fireworks exploded at the height of 64 meters. Now we are done solving the problem.
Students, we have come to the end of this video. But before we end this video, let us recap the things that we learned in this chapter. For the first subtopic, we have learned about the quadratic equation and inequalities. Meanwhile, for the second subtopic, we have learned about the type of roots of quadratic equation. And for the last subtopic, we learn about the quadratic function as shown by using the GeoGebra software. In this subtopic also, we learn about how to sketch the graph of quadratic function, and not to miss out, we also learn how to solve the problems regarding the quadratic function. To summarize, all of the knowledges learned in this chapter will be really useful to be applied in the future, especially in some related careers. We do hope that all of you enjoy this video, and we hope that this video could help you to understand and master this topic. See you in the next time. Have a great day everyone. Bye!